Okay, so let's go ahead and take a look at this lesson. So this lesson is addition, subtraction, and multiplication with square roots. So what we're doing is square roots are like, you can combine square roots like if they were x's, right? So we can treat like the square root of 2 as if it was a variable. And if that's the case, then negative 2 minus 7 gives us negative 5, and then we have square root of 2. And so we can do that. We cannot combine like x's and y's together. So when I have my root 6 and root 6, I cannot combine it with my root 3. So this would give me a negative 4 root 6 plus 3 root 3, and I couldn't do anything with the 3 root 3. Now with 48 and 75, what we can do is, they're not the same yet, but maybe we can reduce them to be the same. So remember that I can pull out some perfect squares. Like let's just say I did not know that 48 was divisible by 16, right? Maybe I didn't know. So I can divide it by 4, and then that would give me 12, and then I could divide it by 4 again and get 3. So then this would be 2 times 2 root 3, so this would be 4 root 3, okay? And then the other one is divisible by 25, so that's root 25 and root 3, so this is 5 square root of 3. Now I can combine these together. Remember that there was a subtraction sign between them. So this is 4 root 3 minus 5 root 3, which gives me a negative 1 root 3. Okay. And so all of these, when we simplify roots, we're going to have to see what we can divide out. So I would take them separately like I just did. Like anytime I have them, I would take them separately. So the square root of 92, I'm like, all right, well, let's see. Possibly divisible by 4. So let's go 192 divided by 4 gives me 4, 16, 32, 8. That's also divisible by 4. 4 and 12 and divisible by 4 again, which is 3. So I have 3/4, and I have the square root of 4, square root of 4, square root of 4, and the square root of 3. Okay. Now, get embarrassed by your arithmetic, erase it and pretend like it doesn't happen. Okay, so now I have 108, right? So 108 divisible by 4, 2, 8, 28, and 7. Oh, look, divisible by 9. So 9 and 3. So then this is minus a 5/6, and I have a root 4, root 9, and a root 3. Okay, so then my first one has a 3/4, and I have 2 times 2 times 2 times 2, which is 8, root 3, minus 5/6, and I have a 2 times 3 and a root 3. So my 8 and my 4 can reduce, so that gives me a 6 root 3. And then I have minus, so my 2 and my 3 and my 6 can reduce, so that gives me a 5 root 3. And then 6 minus 5 is 1, so I get 1 root 3. Okay, I got a lot of these examples all the way to 7, but I want to show you guys the difference between the with example 6 and 7. That's actually really important. Okay, so let's take a look here. When I have an x squared, though, I guess I can start off with blue like I did the last time. An x squared, that's a perfect square, so that one of those x's will get simplified. So I really have a 2. I have a root 4, a root x squared, and a root 2. And that's what simplifies in this first fraction here. And then I have a minus 5x, and 32 is root 4, and a root 4, and a root 2. And then my last one is a plus 5. 18 is 9, and then I have an x squared, and I have a root 2. Okay, so now let's do a little bit of simplifying. 2 times 2 times x root 2. Then I have a minus 5x. 2 times 2 times root 2. And then I have a plus 5 times 3 times x and a root 2. So that gives me 4x root 2 and a, let's see, 5 times 4 is 20, so a negative 20x root 2. And then a plus 15x root 2. So now since all of these have x's here, right, and they all have root 2's, then I can simplify them. But if they did not both have, all three of them didn't have an x, or all three of them didn't have a root 2, then I could not really simplify it down. But I can do 4 minus 20 is a negative 16, plus 15, so a negative x root 2. Okay. And what I wanted to show you guys before is there's a difference between, like, people think that you can distribute the square root, right? So you cannot distribute a square root. These are not the same value. So I cannot take something like this and separate it out like this, because on the left, square root of 25 is 5, and then this is 12, right? And then 20, and that's 17. And then on the right-hand side, 144, right, and 25 give me 169. And the square root of 169 is actually a perfect square of 13. These two are not equal. So you can't take a square root of something that's being added together. We call it like holding hands. And you can't separate it out into two separate things. Okay, because they are not equal to each other. Same thing here. I can't take a square root, like if the square root, the negative underneath the square root is different than the negative outside of the square root. So this is actually I root 169, so 13i, whereas this is a negative 8 because the square root of 64 is 8. Okay, and so that where you put the negative sign actually does matter. Okay. My notes pages were out of order, so I missed a few examples. Okay, so now we got to do a little bit of, more simplifying. And what you notice is that my 48 is a number that's divisible by 4. It's actually divisible by 16 also, but let's just say you don't know, right? Like, how do I simplify? I'm going to try to see if something's divisible by 4 or divisible by 9, right? That's my hope. And if I have to divide multiple times, then that's okay, right? So if I divide by 4, I get not 16. I would get 12. And then if I divide by 4 again, I get 3, right? So I have 4 minus root 4, root 4, root 3 all over 2. So 4 minus 4 root 3 over 2. Now what you notice is that there's a greatest common factor in the numerator. I could pull out a 4, and I'm left with a 1 minus root 3, and this is all divided by 2. Now this 4 outside of here and this 2 that's in the denominator can reduce. I don't reduce anything that's in that parentheses because it's being multiplied, right? So then I have a 2 out here. So then I get a 2 times 1 minus root 3. And I can leave it like that. The other way you could have done it too is I could have taken that 2, and just like when we did the quadratic formula, I could have divided both terms by 2, and I don't divide, remember, underneath the root. Okay? Now, when I do multiplication, my numbers in front can multiply, and then my numbers underneath the root multiply. So then that's a root 20. Square root of 20 is divisible by 4, so that's root 4 times root 5. So then I have 18 times 2, and then a root 5. So 18 times 2 is 36, root 5. Okay, same thing again. My numbers in the front multiply, so that's 30. My numbers underneath the root multiply. And then I got to tell you, like, I don't know if I would really... I don't know if I would go and take 6 times 18 and multiply it together just to have to pull it apart again. So I probably would have done this. I would have probably done 6 times 6 is 2 times 3, right? And 18 is 9 times 2, right? Because 9's a perfect square. And then my p's, I have 4 p's. So I have a p squared and a p squared. So I would have broken it down into try to break them down into perfect squares, because then what I would have noticed is that, oh, here's a 2, right? And here's a 2. So that would make 4. So what I have is I have a 30 on the outside. Then I have a root 4. And I also have, I guess I can change colors, a root 9, right? And then, change colors again. I don't know, red. And then I have a couple p squared. So I have a root p squared and a root p squared. And then the only thing I have still left underneath there, I guess, is in the poop color, which is a square root of 3. So now, I can very easily, look at my perfect squares. Here's a 2. Here's a 3. Here's a couple of P's, right? And here's a poop color root 3 that I have left over. And so now I have 6 times 30, which is 180. And then I have a P squared and a root 3. So I don't think I would have done like 18, times 6 just to multiply it out and to pull it back apart again. I feel like that's kind of like inefficient. Okay. All right, so now I'm going to go ahead. I'm going to distribute my root to both things. I have 4 root 2 minus the square root of 20. And now I can simplify the square root of 20. So I have 4 root 2 minus a root 4 and a root 5. So I get a 4 root 2 minus a 2 root 5. I cannot combine these together because the roots are not the same, so that's just my answer. Okay. Now, just like when we did, multiplying polynomials and stuff like that, where we use the box, we can use the box here too. So, and that's probably what I would do. It's just a little bit cleaner that way. And I'm not always a box fan when it comes to like multiplying out polynomials, but I will tell you that with roots, I would definitely probably do the box, because it will make your life a little bit easier as far as keeping record of everything. Okay, so this will be 3 times square root of 4, which is 3 times 2, which is 6. Okay, and then I have minus a root 10. That root 10 is not going to simplify. Then I have a 12 root 10, and that's not going to simplify. And then I have a minus 4 root 25. Square root of 25 is 5, so negative 4 times 5, which is negative 20. So I have a 6 minus root 10 plus 12 root 10. I just want to make sure I didn't make a mistake. And then minus 20. So then I get a negative 14, and then plus 11 root 10. Okay. Same thing with this example. I would have multiplied this out. I was just looking to make sure that this wasn't completely weirdly out of order. Okay, so 4 and then a minus 2 root x and a 1 and a 3 root x. So that gives me 4 minus 2 root x, 12 root x, and a minus 6 root x squared, which is a negative 6x. So I get 4 minus 2 root x plus 12 root x minus 6x. So I get 4 plus 10 root x minus 6x. And then just like I was just telling you guys about that quantity squared, like I can't distribute a square root. I can't also distribute a squared, which we talked about before when we were multiplying out polynomials. But you have to write this as a 1 plus 3 root x and a 1 plus 3 root x. It's 2 of these parentheses together. So 1, 3 root x, 3 root x, and a 9 root x squared, which is not a 3, a 9x. So I get 1 plus 6 root x plus 9x. Okay, and that is it for this lesson.